Hello guys, once again coming back at you with another video on Precalculus. This is still Mike. In the previous video we talked about angles, the different types of ways that we can measure angles, specifically degrees and radians. How do we convert between the two? And then we talked about coterminal angles as well. In this video we are actually going to begin to get into actual trig and trigonometric functions. But we are going to talk about them in the context of right triangles and right triangle trig. This may be a little bit of a review for you from your previous math courses in high school, but if not, then let's get right to it. So on the left here you see we have a right triangle. Obviously it's a right triangle because the right angle is happening there. And we have an angle theta that measures between 0 and 90. We have two legs of our right triangle, and we have the hypotenuse here. Legs A and B, hypotenuse is side C. This guy right here, this leg A, this is the leg opposite theta. And then this leg B here, this is the leg which is adjacent to theta, aka next to it, because it is the side that is right next to where theta is, and then obviously our hypotenuse, the longest side of a right triangle. So if we know the lengths of these three sides, both legs and the hypotenuse, for a given angle theta, we can determine the values of the six trig functions at this angle theta. So given a right triangle with acute angle theta, the six trigonometric functions of theta are, we have sine of theta, sin. That is the ratio of the length of the side opposite theta divided by the hypotenuse, or a over c. We have cosine of theta, cos, which is the ratio of the side which is next to, or the side which is adjacent to theta, divided by the hypotenuse c. And then we have tangent of theta, or tan theta, which is the ratio of the side opposite theta divided by the side which is adjacent to theta. Now, some of you may only be familiar with these first three trig functions here. You have probably recalled these if you have seen these before. SOH, CAH, TOA. You would probably remember those three with SOHCAHTOA. But there are three more trig functions that you may not be aware of. There's cosecant theta, or CSC theta. This is the ratio of the hypotenuse over the leg which is opposite theta, or C over A. There's secant theta, SEC theta, the ratio of the hypotenuse divided by the leg which is adjacent to theta, or next to theta. And then there's cotangent theta, or COT theta, and that is the ratio of the side that is adjacent to theta divided by the leg that's opposite theta, or B over A. Now, if you take a look at the trig functions that are side by side here, if you look at sine and cosecant, cosine and secant, and then tangent and cotangent, you see that if you take one and flip it, then you get the other. If you take sine and flip it, you get cosecant. Likewise, if you take cosecant and you flip it, then you come up with sine. There's a special relationship. There are some identities that we're going to get to later on in this video that gives us a little bit more clarity on these relationships between some of these trig functions here. But just a basic kind of problem is if you're given two sides of a right triangle, you can figure out the values of the six trig functions for the given angle theta that is inside of that triangle. You solve for that third side. Once you have that third side, you then just use these formulas right here and you make the substitutions. So first example here, a right triangle that has an angle theta such that the leg opposite theta has length 9 and the hypotenuse has length 11. We're going to find the values of the 6 trig functions for this angle theta. So what I typically suggest you do in this kind of situation is you sketch out a picture of your triangle. My triangles are not to scale. They are not perfect. You are not going to be graded on your drawing capabilities or your artistic capabilities at all in this course. I can promise you that much. If you would, I wouldn't be teaching it. So we have an angle theta. Realistically, it doesn't matter where you put the angle. If you put it there, that would have been fine too. But what's important is how you label it. The leg opposite theta has length 9. So this is the leg opposite here. So I'm going to make that 9. And then the hypotenuse has length 11, the longest side there. And we need to find the values of our 6 trig functions for this angle theta. Well, the first thing we need to do is we need to find the length of this missing leg here. Find our b value if you compare it to the picture from the other page. Well, we use our famous formula or famous theorem, the Pythagorean theorem. A squared plus b squared equals c squared, or 9 squared plus b squared equals 11 squared. 9 squared is 81. 11 squared is 121. Subtract over. That tells us that b squared is equal to 40. And that means b is equal to the square root of 40. Obviously, we're going with the positive square root because we're talking lengths here, and lengths are never negative. So now I can substitute this value back in. And now I can write the values of my 6 trig functions for this angle theta here. Sine theta, opposite over hypotenuse. Cosine theta, the side which is next to theta or the side which is adjacent, divided by the hypotenuse. Tangent theta, or tan theta, the side opposite divided by the side which is adjacent. Then we have cosecant. And again, referring back to the previous page, we said that to get cosecant, we can just take sine and flip it. So top becomes bottom, bottom becomes top. So cosecant theta is 11 over 9. Secant theta, again, to get secant, we take cosine and we flip it. So it's going to be 11 divided by the square root of 40. And then to get cotangent of theta, take tangent and flip it. So we get the square root of 40 divided by 9. So that's how we find the values of the 6 trig functions for theta given 2 sides of a right triangle. Now note that if you see a question like this on any homework or quiz or test, here I wrote the answers with square roots in the bottoms of fractions, specifically here and here. You may have to rationalize those bottoms for the sake of putting them into my math lab, but these are the answers you would have. These are the values of the 6 trig functions for our given angle, our unknown yet given angle theta. One more here, same type of thing. A right triangle has an angle theta such that the leg which is adjacent to theta has length 5, and the leg opposite theta has length the square root of 56. Find the values of the 6 trig functions for theta once again. So I'm going to actually challenge you on this one, challenging maybe using that a little freely in some cases, but try to figure this one out on your own. Create your triangle, label your angle theta wherever you want, as long as it's not where the right angle is. Label your triangle appropriately, figure out that missing side, which in this case is going to be the hypotenuse, and then use those values to find or to write the values of the 6 trig functions. So press pause, try to solve this guy on your own. Once you think you have it, press play, and we'll see if you were correct. Okay, so let's see if you came up with the correct answers here. Here I have my triangle sketched on the left-hand side here. Again, the leg which was next to theta had length 5. The leg opposite theta had length the square root of 56. If you use the Pythagorean theorem, you should have gotten the length of 9 for your hypotenuse there. So now we're just going to take these values, substitute them into our formulas, and see what we get. Sine of theta, opposite over hypotenuse, radical 56 divided by 9. And then from there you can easily figure out cosecant 9 divided by the square root of 56. Cosine 5 over 9, which means secant theta is 9/5. And then tan theta, opposite over adjacent, radical 56 divided by 5. And then cotangent is thus 5 divided by the square root of 56. So there we go. Those are the values of our 6 trig functions here. So not too complicated of problems, just one little calculation that you have to do before you actually write out your answers. Well, some right triangles are special. And when we have these special right triangles, we have, I put nice in air quotes because they're not actually the nicest looking things in most cases, but in the world of trig functions and values of trig functions, they are the nice values. First one here, if your two angles that are not your right angle are both 45, then by definition, those legs have to have the same length, A. And then if you use the Pythagorean theorem, you'd find that A times the square root of 2 is the length of your hypotenuse. So using these basic formulas up top here to find our 6 trig functions, we're going to focus just on sine, cosine, and tangent here because these are the main ones. Sine of 45, A divided by A times the square root of 2. That gives you 1 over the square root of 2, or more commonly, it's written as radical 2 over 2. We just rationalized the bottom there. Cosine of 45 is going to be the same thing. We have, again, A divided by A times the square root of 2, which turns out to be the same thing, radical 2 over 2. Tan of 45, opposite over adjacent, A over A, that just gives me 1. So that's one of our special triangles. That's a 45, 45, 90 triangle. Another triangle that's important is a 30, 60, 90 triangle. If you have a right triangle, angles measure 30, 60, and 90. And if the side opposite the angle 30 has length A, then by definition, the hypotenuse has length 2A. And if you use the Pythagorean theorem to find that third side, you'd find that that other leg, or that third side, has length a times the square root of 3. So, using these values now inside of our formulas up top, sine of 30, opposite over hypotenuse, a over 2a, or 1/2. Cosine of 30, adjacent over hypotenuse, gives us radical 3 over 2. And then tan of 30, opposite over adjacent, 1 over the square root of 3, or when rationalizing, you get radical 3 over 3. Now for this 60 angle here. Sine of 60, now opposite over hypotenuse, gives us radical 3 over 2. Cosine of 60, adjacent over hypotenuse, a over 2a, or 1/2. And then tangent of 60, opposite over adjacent, the a's cancel out, and you're just left with the square root of 3. In a little bit, we're going to be touching on this more. But now we have some trigonometric identities that you'll want to just keep in the back of your mind. You can use these things to make your life a lot easier later on in this course. First up are the reciprocal identities. I already hinted to this earlier on in this video. We said that to get cosecant, you can take sine and flip it. Likewise, to get sine, you can take cosecant and flip it. What does that mean? Sine is 1 over cosecant, or cosecant is 1 over sine. And we have the same kind of thing happening with cosine and secant, as well as tangent and cotangent. Take one, flip it, you get the other. The next set of identities I want to give you are the quotient identities. Tangent is sine divided by cosine, and cotangent is cosine divided by sine. If we look back at our formulas there, sine of theta was a divided by c. Cosine was b divided by c. Well, if you're dividing by a fraction, that's the same thing as multiplying by its reciprocal. So a over c divided by b over c is actually a over c times c over b. The c's cancel out, and you have a over b, which was identically tangent of theta. And then since we can get cotangent by taking tangent and flipping it, you get cosine over sine for cotangent. And then the third set of identities I want to show you here, the Pythagorean identities. Sine squared plus cosine squared equals 1. More specifically, sine squared theta plus cosine squared theta is equal to 1. 1 plus cotangent squared theta equals cosecant squared theta, and 1 plus tan squared theta equals secant squared theta. You can actually get these two from this one here. If you divide both sides of this guy by sine squared theta, you get this one. And if you divide both sides of this guy by cosine squared theta, you get this one here. Just recap of a term. Two positive angles are complements if their sum is 90 degrees or pi over 2. So I want to look at a right triangle, just a general right triangle here. If I have a given angle theta, and this angle here is 90, then we can easily calculate the third angle there. Recall that the sum of the angles in a triangle have to add up to 180. So 180 minus 90 minus theta gives us 90 minus theta. So note that sine of theta, which is a over c, is equal to the cosine of this angle here. It's equal to the cosine of 90 minus theta. Similarly, the cosine of theta, b over c, is equal to the sine of 90 minus theta. And there's a special term for functions like these. Any two functions, f and g, such that f of theta equals g of 90 minus theta, these things are called cofunctions. And they're aptly called cofunctions because it's sine and cosine. The other sets of cofunctions that we have are secant and cosecant, as well as tangent and cotangent. Thus, they're aptly named cofunctions. So these are just the general formulas that are there. A bit later on in this course, you could use these guys to perhaps make your life a little bit easier, but realistically, in the grand scope of things, they're not really used all that often. It's just a good thing to see. But last thing I want to talk about in this video is solving word problems using trigonometry. Typically, the types of problems that you'll see will involve some sort of pretend horizontal line and some pretend line of sight that you have to some object or to some part of an object. So if the object that you're looking at is above the horizontal, the angle that's formed between the horizontal and where you're looking at, that angle that's formed is called the angle of elevation. If the object that you're looking at is below the horizontal, like say you're standing at the top of a building and you're looking down at something, the angle formed by where you'd be looking straight ahead versus where you're looking down at, that is going to be called the angle of depression. So here are a couple real world type situations where we can use trig to solve these guys. So first one up, suppose you're standing 650 feet from the base of a building and you know the angle of elevation from the ground to the top of the building is going to be 40 degrees. What is the height of the building? Round your answer to the nearest whole number. So just like when solving those right triangles and writing the values of our 6 trig functions, I would always suggest that you sketch out some sort of a picture and see and just give yourself a better visual as to what's actually going on here. So I know that I'm standing 650 feet from the base of some building. Just focusing on the one side of my building here. And I know that the angle that's formed by where I'm standing and looking up to the top of this building is 40 degrees. I want to know what the height of this building is. I want to know what that H value is. Okay, so what you have to do at this point, once you've labeled your picture, you have values on there that you have correctly taken from the word problem, is you have to look at the sides of this right triangle that you're given and figure out what trig function do I want to use here. And when you're trying to figure out what trig function you want to use, only think of sine, cosine, or tangent, because you're going to have to pull out your calculator and plug a certain angle in, and you need something that can easily do the calculation. So just think sine, cosine, or tangent here. So I'm looking at my picture here. I want to know the side that's opposite the angle. I know the side that's next to my angle. What one of those three more basic trig functions involves adjacent and opposite, that would be tangent. So the tangent of 40 equals opposite, H, divided by the side which is adjacent, 650. So I now just need to solve for h. I'm going to multiply both sides by 650. So if you pull out your calculator and making sure that it is in the proper mode, our angle is given in degrees, so you want to be sure that it's in that mode. If you do the tangent of 40, you get 0.839099 and then some places afterwards. But if you multiply that number by 650, we're rounding to the nearest whole number. If you take tangent of 40 and multiply it by 650, you get 545.4147, but rounded to the nearest whole number, that's approximately 545 feet. So there we go. That's all we have to do to solve this one problem. In general, draw your picture, label your picture, figure out the proper trig function to use, and then calculate away. Another one here, you're standing on the top of a 300-foot high building and looking down at your friend in the distance. Why you've planned this out with your friend, I don't know. Maybe you're just very tired, or you've been drinking, whatever. If the angle of depression is 37 degrees, how far is your friend from the base of this building? And round your answer to the nearest tenth of a foot. So once again, I'm going to sketch out my scenario here. Here's the building that I'm standing on top of. That's me there with the X. Hans is also in there too. And then we have some distance. Here's your friend down there. And it says that the angle of depression is 37. So what we're talking about here is if you drew out this horizontal line, pretend that this is just me looking straight out, this angle here is what's 37. Well, this height here, if we picture a rectangle, this height here is 300 as well. So I want to know what is this distance d here, or equivalently, that distance there. So what I'm actually working with in terms of my triangle, my right triangle, is actually this thing is actually that thing there, what I've lightly shaded in pencil on the edge there. So again, let's figure out what trig function we need to use. I know the side opposite my angle. I want to know the side which is next to my angle. Again, what trig function involves adjacent and opposite? It's going to be tangent once again. So the tangent of 37 is going to equal opposite divided by the adjacent, or my distance d, that thing that I want to find. So if I multiply both sides by d, I find that d times the tangent of 37 is equal to 300, or d equals 300 divided by the tangent of 37. Once again, making sure your calculator is in the proper mode. If you do 300 divided by the tangent of 37, and it says round to the nearest tenth of a foot, you get 398.1134, but to the nearest tenth, that's 398.1 feet. Again, making sure your calculator is in degrees mode here, not radians. So these are just a couple real-life sample problems to see how we can use trig in order to determine distances or lengths or heights or anything of that nature. Guys, this concludes our video on the introduction to trig, specifically trig in the context of a right triangle. In the next video, we're going to talk about the trig functions in terms of a circle of general radius r, and then we're going to talk about reference angles and how values of trig functions at reference angles relate to values of trig functions at some larger or just some odd angle values. If you have any questions or comments, please be sure to reach out to me. Emails, SOSs, flare signals, whatever you have to do. Otherwise, until the next video, take it easy, guys.